Okay. Okay, we got a lot of things to talk about then. First, we'll go over poly 4 and then the last lecture on poly 5. And we're only going to do one practice test because the test is on Thursday. So, oh, all right, only got 3 problems. It means you guys are pretty good then. So tomorrow's quiz is going to be on poly 3 and poly 4. So the word problem is going to have one word problem, but it's going to have part A, B, C. So if you screw up part A, it's pretty much all over but the trying. But you know, because yeah, again, no, I guess you still could get answers for the other one. Well, we'll see. Anyway, show that this equation has no rational roots, but that it does have an irrational root between x equal 1 and x equal 2. Well, first of all, now tomorrow you're going to have to do this. You're going to have to list the possible rational roots. Okay, how do you figure out the possible rational roots? Factors of p over factors of q. What are the factors of 3? 1 and 3. What are the factors of 1? 1. So if you take all the combinations, it's going to have plus or minus 1, plus or minus 3. Except tomorrow they'll have way more than that. And don't forget to put plus or minus now. Okay, well, is 1 a root? How can you tell if 1 is a root of this equation? Yeah, you just plug it in, right? If you plug it in and it comes out to 0, it's a root, right? So if you plug in 1, does it come out to 0? 1 plus 1 minus 3, is that 0? What about negative 1? Does it take that long to plug in negative 1? Here, let me write it out for you. Negative 1 plus 1 minus 3. Is that equal to 0? No. What about 3? 27 plus 9 minus 3 equals 0. Wait, let me get my calculator. Are you serious? What about negative 27 plus 9 minus 3? Is that equal to 0?
No.
No. In fact, maybe I better put the 1 here because someone will be going, what? So here are your possible rational roots. These are the possible rational roots. In other words, if this equation has any rational root, it has to come from this list. But none of them work. So therefore, what can you conclude? This is why you got to be able to think logically. This equation has no rational roots. Okay, now, part B. Show that it does have an irrational root somewhere between x equal 1 and x equal 2. Now, this is a super important concept. It's going to be on the test now. Think of this as a graph, y equals. Okay? Think of this as a graph. What is y of, what did we try to find between 1 and 2? What is y of 1 equal to? Plug in 1 and you get? Gosh. If you cannot even plug in 1, just go home already without cooking rice.
Negative 1.
Thank you. Negative 1. And what about 2? Okay, let me give you the intermediates. 8 plus 4 minus 3, which is 9. So why does there have to be some irrational root somewhere between 1 and 2? Yeah, think of the graph. Here's 1, here's 2. When x is 1, the y-coordinate is negative 1. But when y is 2, when x is 2, the y-coordinate is 9 up here. To get from this point to this point, now remember, polynomials are always continuous. See, one of the properties of polynomial functions, they're always smooth and continuous like that. There's no breaks in them, there's no sharp points. That's how polynomial functions work. So, to get from here to here, don't you have to cross the x-axis somewhere in between? To get from negative to positive, don't you have to hit 0 somewhere in between there? Yeah, and that's why. Unless you're like the last couple years ago, some students were saying, can't you just go around the x-axis to that point? Now some of you are thinking, yeah, can't you do that? No! Well, first of all, if you could, well, how could you if the x-axis goes on forever? And another thing, if you did that, this wouldn't even be a function. What's a function? Oh gosh. So does everybody understand this concept? Super important. Okay, well, we'll see, won't we? Okay, number 6. Oh, word problems. This is one of the problems tomorrow, except you don't know what it is. A right circular cone with height x has a slant height of 3. Hey, Pythagorean theorem. Come on, you know you're going to use the Pythagorean theorem. Are we good at this now? Just look at that. That's the square root of 9 minus x squared. X squared minus 9. X squared plus 9. It's 9 minus x squared. And if you don't know, do the box method, but hopefully we don't have to do the box method. Write the volume as a function of x. Well, what's the formula for volume of cone? 1/3 pi radius squared times the height. Now look at this picture. What is the radius? Are you serious? It's this thing right there. Square root of 9 minus x squared. What's the height? X. And there you go. Simplify. Don't forget this 1/3 now. Because if you forget the 1/3, oh boy. Pi over 3x times 9 minus x squared. See, that's why it's always good to have the radius being the radical thing, because you're going to square it. And what a surprise, we have a cubic function. Find the values of x that yields a volume of 10 pi over 3. So where do I plug in the 10 pi over 3? Where do I plug in the 10 pi over 3? We want the volume to be 10 pi over 3, so where do I plug it in? For v, 10 pi over 3, the pi's cancel out, the 3's cancel out, so this is what we have left. 10 is equal to x times 9 minus x squared. And then you gotta solve that equation. How do you solve an equation when the power is 3 or bigger? Or when it's 2 or bigger for that matter? Make one side. Okay, first we need to multiply it out. So 10 equals 9x minus x cubed. Make one side 0. And notice how I always make the first term positive. You run into less problems if you make the first term positive. So what do? You want to factor by grouping, or should we just do synthetic division? Factor by grouping.
I want to see how you.
You guys want to do factor by grouping?
Yeah.
You can do that tomorrow. I doubt it. You guys would do factor by grouping tomorrow?
I already did something, so I want to see what it looks like.
What about the rest of you? Who wrote number 6 on the board? What are you going to do tomorrow? I know from experience, I've been teaching this class 27 years. You guys not going to do factor by grouping tomorrow. Well, maybe 1 or 2 of you just to challenge me, but you're going to do synthetic division tomorrow. Okay, let's do it both ways. Tomorrow, you're going to do synthetic division. Okay, so what should I try? Factors of 10 over factors of 1. So that's plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Where should I start? Rhymes with bun. 1. But can you see 1 doesn't work? Because if you plug in 1, you don't get 0. So the next number I would try is 2. So please work. It worked! Action! So, what does this stand for? X minus 2 is one of the factors, and then you look at that. That's x squared plus 2x minus 5 equals 0. That doesn't factor anymore, so you quadratic formula. So what are your 3 answers? X equal 2, quadratic formula that. Negative 1 plus or minus root 6. Box set, that's the answer. See, I can do quadratic formula in my head quickly, but can you? Can you do it slowly on a piece of paper at least? See, you guys are just copying that down. What's going to happen tomorrow? Some of you have problems. You guys remember the last quiz? You guys couldn't even come up with a thing. Box that, that's the answer. No moose breath. Why not? Because what is the, not just positive, what's the domain of this problem? X has to be between, you know what, I'm going to make you, just for that, I'm going to make you make the domain tomorrow. Obviously x represents a length, it has to be bigger than 0, but it can't be bigger than 3, because otherwise you can get a negative number in the radical, right? Or think about it this way. If you have a right triangle, the hypotenuse is always the biggest side, right? X cannot be bigger than 3. So, are any of these numbers not between 0 and 3? Yeah, this one. What about negative 1 plus root 6? Sometimes you gotta cross out more than 1, you know. What is root 6? 1 point something, 2 point something, 3 point something, 4 point something? What? It's 2 point something. So what's negative 1 plus 2 point something? 1 point something, which is between 0 and 3, so that one's okay. Plus, that's what it says on the bottom of the page, right? You're not going to have a bottom of the page tomorrow. No, there will be a bottom, just don't have answers there. You guys are, oh! Tomorrow could be painful then, yeah? See, so if you forget, you know what a common error is? What if you forgot this 1/3? Let me just ask you this. What would happen if you forgot the 1/3 tomorrow? No, because if you forget the 1/3, I would just take off -1 for part A. But part B, you can have an equation that's unfactorable. So therefore, you can have -4, minus everything of that. You know what I'm talking about? Don't forget the 1/3. Okay, now you said something about factor by grouping. Okay, how would I factor by grouping? Mason, Takata, did you guys do factor by grouping?
Yeah.
Oh, see? X cubed. Come on, 9th graders. Get up a notch. So what you gotta do is you're gonna have to split up the 0x squared into 2. Let me ask you this. Will this work? See, let's just see if you have foresight. Will this work? Will that work? No, why not? Why won't that work? Because first of all, look at that. You cannot even factor that. You have to be able to factor it, and on top of that, you have to have the same factor as you have here. So then what? What about this? Will that work? Maybe. Let's try. If you group the first 2 terms, what can you factor out? X squared, and then you have x minus 2. Now if you group the last 3, can that be factored? Let's try. 2x and x. Oh boy. 5 and 1. No, 5 and 1 don't even work. That doesn't even work. Does it? Oh, the other way. 5 and 2 minus, well, there it is! It works! Because look, now you have x minus 2 and x minus 2. So x minus 2 times x squared plus 2x minus 5. And that's the same step you have right here, yeah? See, that's the hardest part. You gotta figure out, how do I split up the 0x squared? That's what you gotta figure out. You gotta kind of have foresight. You gotta see to the next step. Alrighty, and then finally, number 8. Wow, you guys are not bad then on this worksheet. And are you guys cheating on number 1? Like when you do problem 1E and 1F, are you guys cheating? Or 1D? Are you looking at the answers on the bottom? I don't know, Mr. Park, I never did it yet. Strike 1! We had 3 nights to do this. You know, just for that, I want to see. I'm going to walk around the room. Show me 1F, Lynn.
Right there.
You had 3 nights to do 1 homework assignment. I don't want to shout out any names for the video. Paige! Tang? Then why do you guys don't just put it on the board? Ma? You don't have anything. Okay. You just copying down what I'm writing on the board. We had 3 nights to do 1 homework assignment. I should have just done what Miss Kingsley did. Just blast through. Should have had the test on Friday.
No.
So what are you guys gonna do then tomorrow? What's gonna happen tomorrow? Plan D for you guys. Plan D, just Just try not to get a 0. Is that it? And then what about the test? You guys, oh, that's good. No. Feel the pain. Feel the pain. Well, you guys are gonna come through. You're just gonna clutch up. Clutch up tomorrow. Is that it? Well, it hasn't worked so far, has it? I keep telling you, whatever you did last year, it's not gonna work. It's not gonna work. You gotta kick it up a notch, man. Probably, I'm sure you figured this out by now. Okay, we have a wooden block. It dimensions n by n plus 3 by n plus 9. You know what? Just for that, the probability of this being on tomorrow's quizzes just went up to 0.93. And then you're gonna cut it up into unit blocks. You know what unit blocks are? Unit means 1. It means they all have, like, they're all 1 by 1 by 1. Okay? The surface of the block is painted, and the block is then cut into 1 centimeter cubes by cuts parallel to the faces. If exactly half of these cubes have no paint on them, what are the dimensions of the original block? Okay, first of all, you gotta understand the problem. You have this block, you're gonna paint the outside, only the outside. How many blocks do not have paint on them? How many people got this problem? 1, 2, 3. So just look at this corner from now, don't even look at the other parts of the class. Gosh. Okay, no, we're not gonna do anything until somebody comes up with something, somebody that didn't do the problem. How many blocks do not have paint on them? Well, let me ask you this, how many total blocks are there? N times n plus 3 times n plus 9, right? Okay. How many blocks do not have paint on them?
N minus 2.
Yeah, there you go. N minus 2 times
N plus 1.
n plus 1 times
N plus 7.
n plus 7. What? Think about it. Okay, only the outside has paint, right? The inside blocks don't have paint on them. So if you strip away the outside layer, right, you take away the front layer and the back layer. So if this is n plus 3, if you take away the front layer and the back layer, what is that going to become? N plus 1. You take away 2, right? The front and the back. Now if this is n, what if I take away this layer and the one on the opposite side? Don't you get n minus 2? You just subtract 2 from each dimension, basically. You get it? And then what about this? This is n plus 9. If you take away the top layer and the bottom layer, it becomes n plus 7, right? That's how many blocks do not have paint on them. And what is that equal to? It says half the blocks do not have paint on them. So what is this equal to? What's the total number of original blocks? N times n plus 3 times n plus 9, right? And then you divide it by 2, that's half. So half of the original number of blocks don't have paint on them. This is your equation. Okay, I'm going to leave it to you to solve. Now, every single year, I tell the students this. Okay, finish this problem. Every single year, about 1/3 of the students will get -5 on their homework because they didn't finish it. So you got to finish this by Thursday now. All you got to do is multiply it out, make one side 0, and do synthetic division. Or you want to take the challenge, factor by grouping. I'll leave it up to you. Okay, are you sure there's no questions then? Okay, of course. Period 3. Just for that, I'm going to check every single class. 3 days to. We're going to homeroom. We're going to homecoming mode for a reason, to help you out. But no, I give you a little bit, you want more. I give you $5, you want 7. I give you 7, you want 10. Strike 1. Okay, today, now all of this is review from last year. This is all review. Okay, now we're going to learn something new. Okay, look, you guys should be reading your notes as you go through this, because I'm not, well, some of the things you guys learned last year, but I'm not really sure. Okay, let me ask you this. Okay, write me a polynomial, right? A polynomial equation with integral coefficients. What does that mean? Integral. You gotta know that word. What does integral coefficients mean? Integer coefficients. That means no fractions, no radicals. So that its roots are, okay, let me think. -3 and 1 plus I root 2. Write me a polynomial equation so that the roots are -3 and 1 plus I root 2. Didn't you guys do something like this last year? Yeah, because I saw your quiz, Mr. Buba showed me. So tell me, what is the degree of this polynomial going to be? It's going to be degree 3. Why? How come it's not 2, but Mr. Park, you only see 2 roots? What did we learn last year? If 1 plus I root 2 is a root, what else also has to be a root? -1 minus I root 2. Why? Yeah, because from the quadratic formula, right? Are you guys looking at the notes? It's right in there. If A plus radical B is a root, then A minus radical B gotta be a root. If A plus BI is a root, then A minus BI gotta be a root. Because the irrational ones and the imaginary ones always come in conjugate pairs. So we're looking at a cubic polynomial. It's gonna be degree 3. So how do you do it? Well, let me ask you this. Write me a polynomial equation whose roots are 1, 2, and 3. What would you do? Yeah, you just go x minus 1, x minus 2, x minus 3 equals 0, and there you go. And then I'm going to ask you to multiply it out, though, so that you multiply it out. Okay? Oh, so what about this? What would you do then? X plus 3 times x minus this. So what is x minus this? So, just like that. It's the same thing, except the numbers are different. X minus this, which is? Okay, I'm just going to stand here till I hear it. You want to play the waiting game? I can play the waiting game. No. Plus. And then x minus this. Equals 0. And then multiply it all out. Is that the way you guys learned last year? Takara? Okay, then, yeah, then multiply it all out. But you know what? What would happen if you guys multiply this out? Pain, that's what's gonna happen. Here, let's try it. Okay, I'm gonna call on people at random. Kane! Multiply this out. Quickly.
X squared plus 1.
Oh gosh.
Wait, sorry.
You take the first term and distribute it.
Oh, x squared plus x squared root 2 plus x plus 1 plus I root 2 minus x I root 2 minus I root 2 minus 1 2 no
I Well, what's root 2 times root 2?
2
And what is I times I?
-1.
Okay.
Oh, sorry, -2.
No.
Or plus 2.
Plus 2. Because I squared is -1. And what do you notice? What do you notice? Hey, Mr. Park, Monsieur Park, look, this cancels this. Oh, Mr. Park, all the i's and radicals cancel out. Duh, they have to, because otherwise how are you gonna get integer coefficients? They have to cancel out. So if you do all that work and they're not canceling out, you did something wrong. Okay, so you get x plus 3 times x squared, what's left? Plus 2x plus 3, did I do that correctly?
What was the question?
Did I do that correctly?
Oh yeah, because you're the teacher.
Okay, thank you. Somebody knows the answer to these. And then now multiply this out. Take the first term and distribute it. Go. Yeah, I love talking to myself. Plus 9x plus 9 equals 0. Woo! There you go. There's your answer. There's got to be a faster way, Mr. Park. Yes, there is. Well, you see, it just depends how much you know. Now, this is the way most peasants would do the problem. But there could be a faster way. Like, you could, like, right here. Right here. You could just take these two, instead of doing a cubic, you could just write a quadratic equation where these are the two roots, because we did this last chapter, right? And then you could just take that and put it here, because you already know for this, you get this factor, right? So here, let's go back to last chapter. If you know the two roots of a quadratic equation, how do you write the equation? What did we do? Remember? The math team's secret way? Or how about the sum of the roots is negative b over a and the product is c over a? You guys remember that? So which one you want to do? Pick one. None. I'd rather just do all this work. Are you crazy? Okay. So negative b over a is equal to the sum of these two roots. What is this times this plus this? What is this plus this? It's negative 2. C over a is equal to the product of the roots. What's that times that? Okay, if we cannot even multiply two numbers, then no sense even do this way. What is that times that? 1 plus 2, which is 3. So if A is 1, B would be, if I plug in 1 for A, what does B come out to? 2, and C would be 3, and isn't that this thing right there? And then you can just put that there, multiplied by that, boom, you can get your answer. But Mr. Park, there's still got to be a faster way than that. Yeah. Well, look at your notes. See, look, in a quadratic equation, what's a quadratic equation? This is a quadratic equation. There are two roots, right? The sum of the roots is always equal to what? I just did it over here. Negative b over a, and the product of the two roots is always c over a. Is there something like that for higher degree polynomial equations? Yes, and this is the, okay, so here's a cubic equation. And the pattern is going to hold for higher degrees. How many roots does a cubic equation have? The highest power tells you how many roots there are. There's 3 roots, okay? If I were to add up the 3 roots of this cubic equation, what do you get? Look at the notes. Negative b over a. If I multiply them 2 at a time, like this, r1 times r2 plus r1 times r3 plus r2 times r3, you will get c over a. And then if I multiply them 3 at a time, r1 times r2 times r3, you will get, no, negative d over a. Do you guys see the pattern yet? Okay, we gotta go one more. Mr. Park, I don't see a pattern. These are just random occurrences. Oh gosh. Now look, I had to erase the original problem. I hope somebody copied it down. What if you have a quartic equation? ax to the 4th plus bx cubed plus cx squared plus dx plus e equals 0. How many roots does this equation have? 4. If I add the 4 roots together, you will always get negative b over a. Oh, so Mr. Park, negative b over a is always the sum of the roots no matter what the degree. Yes. If I multiply them 2 at a time, R1 times R2, and then R1 times R3, and then R1 times R4, and then R2 times R3, and then R2 times R4, and then R3 times R4, you will always get C over A. If I multiply them 3 at a time, R1 times R2 times R3, plus R1 times R2 times R4, plus R1 times R3 times R4, and then R2 times R3 times R4. Did I catch them all? I'm not referring to Pokemon either. Did I catch them all?
Yeah.
What is that always going to equal? Negative d over a. And then multiply them 4 at a time. R1 times R2 times R3 times R4. That's always going to equal e over a. Oh, Mr. Park. This can help me solve that problem faster. First of all, do you guys understand the pattern? Okay, so let's go back to the problem we had. Watch how fast this is. This is like ridiculous. So what were the 3 roots again? I forget. Negative 3, negative 1 plus I root 2, and negative 1 minus I root 2. Is that correct? Okay, so just do this. Negative b over a, c over a, negative d over a. Okay, negative b over a is the sum of these 3 roots. If I add those 3 roots together, what do you get? Quick. Negative 5. How do you add that so quickly? Because these 2 cancel out. Gorilla and negative gorilla. Here, someone's going, what? Gorilla and negative gorilla cancel out. What am I dealing with? Okay, c over a is multiplying them 2 at a time. Okay, multiply these 2. Oh gosh. Multiply these 2. Just write 3. Why? How come you don't want to write the minus 3i root 2? Okay, let's just write it. No, too late. Let's just write it. Minus 3i root 2. Okay, now multiply these 2. Plus 3 plus 3i root 2. They can cancel out. No sense write them. And then, well, here's a nightmare. Multiply these 2. We kind of did it already. Or maybe we just can't remember. What is it? What? 1 plus 2 is 3. Anyway, look. The i's and the radicals cancel out. They have to. Otherwise, how are you going to get integer coefficients, right? Anything with I or a radical is going to cancel out. So why even write it? That's my point. Anyway, what do you get? 9. That was kind of slow. And then negative d over a is multiplying 3 at a time. Now let's see if we can remember anything. I already multiplied these 2 together. What did we get again? 3. So what is 3 times negative 3? Negative 9. So if I let a equal 1, what is b? If I let a equal 1, b is 5, c is 9, and d is 9. Therefore, the equation is going to be x cubed, 1x cubed, plus 5x squared, plus 9x plus 9 equals 0. Was that the same answer we had the last time? Got it? Took that long? You were looking at the thing.
No, I didn't write that.
Yeah, obviously. Did anybody write down the last one? Is that the same answer? Yeah, why would I teach you something that doesn't work? So watch, okay, so this is how it works. So if you want to do this, I don't care how you do it. You gotta do it, okay? Okay, what time is it? Yeah, I know, I wasn't really asking. Let me just show you something. Okay, so I taught you how to do this, but watch. This is how the professionals do it. Remember that answer. So I know it's going to be a cubic polynomial. Watch this. Okay, so this is what I do. I just assume a is 1 already. So this is what I do. X cubed minus something x squared plus something x minus something equals 0. How come you have minuses here and here, Mr. Park? Because negative b over a and then negative d over a. That's why I put the minus signs in already. Okay, now just watch. Here are the 3 roots. Add them together. What is this plus this plus this? Quick. Negative 5. Now multiply them 2 at a time. Multiply this times this. 3. Multiply that times that. 3. Multiply that times that. 3. That's 9. And then multiply them all 3 at a time. 9. Finished. That's the way the professionals do it. All I'm doing is employing this thing right here. But I'm assuming a is 1 already. And then I'm putting the negative signs in already so you don't have to worry about them. Oh boy. Can you feel the pain? You don't do your homework. Wait. You guys didn't even do your homework. You guys even read your mid-quarters? What did it say to do in the mid-quarters? Did it get sent home?
Yeah.
What did it say about completing the assignments on a daily basis? I don't know, I didn't read it, Mr. Button. No, don't listen to me. Okay, write me a polynomial equation whose roots are, okay, we've got time for one more problem. You want to make it challenging or kind of easy?
Challenging.
No, easy. 1, 2, 3, 4. Okay, write me a polynomial equation with integral coefficients whose roots are these. Now, you can just do it the way you were taught last year. Oh, Mr. Park, it's easy. X minus 1, x minus 2, x minus 3, x minus 4 equals 0, and then now multiply it out. This is where all hell's going to break loose, right, when you have to multiply it out. Okay, you can do that. Okay, but what if instead of 1, 2, 3, 4, you got 2 plus or minus root 5? 2 minus, what did I just say? 2 plus root 5, 2 minus root 5, 3 plus or minus, 3 plus I root 7, 3 minus I root 7. Then you're going to do that? I don't think so. This is what you want to do. I'm going to employ this method. Okay? Watch this. What degrees are going to be? Do you have 4 roots? So what? I'm going to assume a is 1. X to the 4th minus something x cubed plus something x squared minus something x plus something equals 0. What goes in there? The sum of the roots. What is this plus this plus this plus this? 10. See it? Gosh, look at the chalk. Okay, now multiply them 2 at a time. See, the pattern is, you haven't figured it out. 1 at a time, 2 at a time, 3 at a time, 4 at a time. That's how it works. Multiply them 2 at a time. Go. 1 times 2. 1 times 3. 1 times 4. 2 times 3. 2 times 4. 3 times 4. Add them up. Here, let me help you. 20 plus 10 plus 5. Is that how you guys learn to add? Group the ones? No, I go like this, Mr. Park. 2 plus 3 is 5. 5 plus 4 is 9. Okay, now multiply them 3 at a time. 1 times 2 times 3. Quick. 1 times 2 times 4. 1 times 3 times 4. 2 times 3 times 4. Add them up. Here, I'll give you a hint. That's 20, and that's 30. 50. And finally, the last one is multiply them 4 at a time. What is that times that times that times that? 24. Boom, finished. That's the answer. Isn't that a lot better than doing that and multiplying it all out? Yeah, but in order to do that, you gotta know this. Okay, so tonight's home night, some of you are going to say, I don't have to know that, I'm just going to do it like this the whole time. Yeah, but then you're not going if you do it that way, you're not going to be able to do the higher level problems, as you're going to find out. You're going to come across a problem tonight. Okay, let me just tell you one thing before the bell rings. Tonight you're going to have to see problems like this. I don't know what the number is. Notice that there is no x squared term. What does that mean? How many roots does this equation have? 3. There's no x squared term. What does that immediately mean to you? Skip to the next problem. No! What? The sum of the roots is negative b over a, which is 0. Yeah, so if you don't have any x squared terms, that means if you add up the three roots, you gotta get 0. Because negative b over a is the sum of the roots. That's how you have to start thinking, people. Oh, this is gonna be a long day for me. I feel it. And 3 days to do one homework and we cannot do it? Over. Make sure you have your calculator for tomorrow's quiz. It's a madhouse!